Integrated 2. Today we're going to start chapter 10, and it's the geometric mean, which I think you'll find is pretty straightforward and simple. So the geometric mean is when the means of a proportion are the same number, okay? So we talked about how there are means and extremes in a proportion, and so they're going to write that again. That would be something you can get down in your notes. The geometric mean between those two numbers is the positive square root of their product. So, here's the words for it. You can kind of read that. They're going to have you find this geometric mean. And so basically, we know that the means are the same. If you look at that, the means are one pair of the diagonals in a proportion. So if I am going to find 5 and 45, you would just set up 5 is to x as x is to 45, and the x's are the matchers. If you were to use cross products, you would have x times x, or x squared, and that equals 5 times 45, which is 225. And then, of course, you would find the square root of 225, and so x would equal 15, and so that's where they're getting that from. Okay, so go ahead and try number 1b. Notice I would prefer you simplify your square roots. That's a little more of a mature math student than always putting things in decimals from now on. So if you can simplify the square root, please do so. Go ahead and jump to the next page. All right, so basically, this theorem 10.1, if the altitude is drawn to the hypotenuse of a right triangle, what you've formed is two triangles. You've formed, in this picture, you've formed ACD and you've formed BCD. You made two other triangles, and those two triangles are similar to each other and to the very, very beginning one. Okay, so there's three similar triangles. So read through this kind of thoroughly there. All right, write a similarity statement. We're going to go and take 2A. All right, so let's say that you didn't know anything about this other than you know that by drawing that altitude, you've made three similar triangles. And so what can happen is I think it's important to actually draw these so you can see what happens here. So we've got the very, very large triangle. Okay, the large one is M, and then K, then L. Okay, so we've got that big one. That's this one. Okay, that's that one. Okay, now we've also got, I'll use a different color here, maybe not blue since it's in blue, this one right here, this green one. So that one I'm going to situate in the same orientation as I did the other one, with the right angle on the bottom left. Now if I did that, you know in that green one that's a P, okay? And so we can also tell by looking at it that K would need to be the larger of the two angles. Okay, so we've got that K here and then M here. Okay, and then the last triangle we've got is this one right here, PML. Okay, so the red one's a little bigger than the green one was, but the angle is still here. That is angle P. That is the letter P. And so we can see visually that PL is the longer side, and we have M up here. So don't just go with thinking that, these are kind of all turned around inside of that shape. So now we're going to make a similarity statement between all of these. So you could say that triangle KLM or KML, looks like they did KML, that's fine. KLM, so I'm going around this way, is triangle, is similar to triangle. So I need to go and say KMP, right there. The order is a little different. Is similar to, same thing, go around the circle there, MLP. So if you notice, my last two are switched around in each one. Theirs is fine and mine is fine. So that's what they mean by making a similar statement. So see if you want to go ahead and get 2b the same answer there. Kind of the same thing there on the bottom, so jump to the next page. All right, 10.2 is the geometric mean altitude theorem. The altitude drawn separates that hypotenuse into two segments. And so what you can do is you can have a statement there that, and I'm going to just kind of write it, that x is to h as h is to y. So if you notice that x and y are on the hypotenuse, that's one way to solve for x or y or h or whatever they might give you. They'll probably give you 2 out of the 3 of them, okay? And then once you do that, you can just use cross products there. And then the other one says is that c, which is the total distance, okay, notice, so really c is x plus y. X plus y is to b one side as b is to the same side. So the total is to, so this is a hypotenuse. So this is a hypotenuse, is to a hypotenuse, as that hypotenuse is to that part of it. They're similar. And then it works for the other side too. So, you know, that x plus y, which is their c, is to a, and a is to y. And so if you notice, those are on the same side. So before I use that, I am going to show you a way to just figure it out without knowing those rules. Like, let's say you get to the test and you don't know the rules. There's always a way to figure it out beyond that, okay, which I sometimes think this is a little more accurate. So the first thing I would do is draw those problems out, draw this triangle out outright. Okay, the very big one, the big triangle, is L, J, and K. And so I'm going to go ahead and label the sides. JL is Y, and 5 and 20, this is 25, you'd have to add those, and LK is Z. Okay, so we know that. Now, if I chose to do the little one, remember they're similar, but it's just smaller. So I'm on this one right here, that one. This is M. Now that smaller, longer side is L, and then J is at the top. So MJ is 5. I'll put that in blue. 5. And it looks like the hypotenuse of that is Y. And looks like that bottom side is X. Then the last one, but surely not least, is the medium-sized triangle, which would be this one, okay? And M is at the right angle. I always find the right angle first, and then it looks to me that the hypotenuse of that is Z, and so that means that this is L and K, and let's see, I should have put this as Z. And it looks like LM is X, and it looks like MK is 20. All right, so what you've got here is you've got 3 similar triangles to play with here. And so I'm seeing a relationship right here with the bottom 2, where I've got 2 X's. And so what if I wrote something like, oops, 5, which is JM, is 2X, so it doesn't matter which X. So 5 could be to 5 is to this X, that's fine, as X is to its 20. Okay, so that totally makes it solvable because you're just going to use the geometric mean. So we know that x squared equals what? 100. And so x equals 10. Step 1's done. We know now that we can use x to be 10. So I can erase these 2 and I can put 10 in there. Now you know that you could use the Pythagorean theorem to find z and y if you wanted. Okay. You could also use the geometric mean for this one. You can say y is to 5 as 25, this one, is to y. So as long as you have that diagonal makes a y squared, we get y squared equals what, 125? And so it's the square root of 125. And so then we know that y, and this y is the square root of 125, and this one is the square root of 125. So the second triangle is already solved. And so then you've got the z, and so I would use this first and the third to set up maybe one more equation. And so you could set up 25 is to z, as z is to 20. And so then you would get the square root of 500 there. So z squared would equal 500, so it's the square root of 500. So let's see what they've got here. They got the 10, they got the square root of 125, and there's the square root of 500. So we have all three sides solved. Like I said, you can use the Pythagorean theorem, but I think they kind of are going with, they haven't introduced the Pythagorean theorem until the next section, so they're probably wanting you to use the geometric mean. Okay, now, we could have probably done that a lot easier by following these two rules. So in the next one, we are going to actually follow those two rules, and I might shuffle back and forth so we can look at those rules again. Okay, jump to the next page. All right, there's the first one. Okay, so the geometric mean, remember, if I want to find z, I can use the hypotenuse. So I can say 8 is to z as z is to 25. So 8 times 25 is 200. So z squared equals 200. And you take the square root of 200, and I'll break that down. Let's see, 100 goes in there, so it's 10 square root of 2. Okay, so we know that z is 10 square root of 2 now. Okay, so that's how you can find the altitude. Now we're going to go and look back a page, if I can scroll back there. This 10.3 again, take a good look at it. The total distance of the hypotenuse is to one side as that side is to that matching side. Okay, it's right here. C is to B. The total is to one side as the one side is to that other chunk of that hypotenuse. So let's jump and do that on 3A here. So we said that the whole entire hypotenuse, 8 plus 25 is 33. 33 is to a side. You just need to pick one. 33 is to y, as y is to the same chunk, the same triangle that the y was with, which in this case is 25. Okay, I can go ahead and write the other one. I can start with the total. 33 is to x, as x is to its chunk 8. So let's see what we get here. Bring up a calculator if it'll let me. All right. All right, so 33 times, or if it's going to have an add, there we go. Looks like I'm going to start it over. There we go. Hopefully it doesn't do it again. Okay, so 33 times 25 is 825. And so you know this would say y squared equals 825. Okay, I'm just going to square root it this time. It is approximately 28.7. We'll look at what they got in a second. 33 times 8 is 264. So x squared equals 264. You take the square root of that. So it is approximately 16.2. All right, let's see what they've got here, if it'll let me get rid of it. All right, let us see, 28, oh, there's 28.7, 16.2, and where's the 10 squared? Right here, I think, is 10 squared 2. Okay, or about 14.1. So that is the easiest way. If you can't remember that way, then go ahead and write the triangles out like I did the last one. So if you want to try 3B there, you can. The answers are 16, 20, and 15. So if you want to work those out until you get that. So that's really all you're doing there is kind of finding the geometric mean and using that to help you solve different parts of the triangle. Okay.